We're going to finish up using our double angle formulas, and this is actually going to be fairly useful to us because sometimes there's these forms that we can use to go backwards to be able to get the exact values. So we have this 2 cos squared of 105 degrees minus 1. And you probably remember that we have that cos of 2x is equal to 2 cos square x minus 1. And so all we're going to do is we're just going to substitute x back in here. And again, we just look at our formulas, okay, and notice that we have cos 2x is equal to 2 cos square x minus 1. And so we're just going to substitute 105 back in for x. So this is going to be the cosine of 2 times 105 degrees, which is the cosine of 210 degrees. And then we can just go into our unit circle, or remember that it's a reference angle of 30 in quadrant 2. It's going to be equal to negative 1/2. All right, so we go to our unit circle, we go to 210 degrees, we go to the x coordinate, excuse me, it's going to be negative root 3 over 2, okay, since it's the x coordinate. So this will end up being our opposite of root 3 over 2. Right. Same thing with this animal right here, this 2 sine of pi 6 cos pi 6. Now remember, we have that sine of 2x is equal to 2 sine x cos x. Okay, so that's our formula. And in this case, x is going to be equal to pi 6. And so we can rewrite this now as the sine of 2 times pi 6, which is the same thing as the sine of pi thirds by simplifying that out. And we know that the sine of pi thirds is positive root 3 over 2. If we don't know that, we just go into the unit circle and look at the y coordinate, and right here at 60 degrees or pi thirds is root 3 over 2. Okay, so nice and easy. This one's a little bit sneakier because we have 4 sine of pi 12ths over cos pi 12ths. Now, if it was 2, that would be really easy. So let's do this. Let's factor off a 2 and rewrite this as 2 times 2 sine of pi 12ths cos of pi 12ths. Or we can write that as 2 times the sine of 2 times pi 12ths. All right, so again, we're just using the exact same formula, okay, this formula right here. And we're just making the sine of 2 pi, the 2 sine of x cos x equal to sine 2x, right? This is going to turn into 2 times the sine of pi 6. And we know on our unit circle, sine of pi 6 is a half, so we get 2 times a half, which just turns into 1, okay? Similar, we can go through and try to reduce this, the tangent of 3 pi eighths, okay? So remember that tan of 2x is equal to 2 tan of x, 1 minus tan square of x, okay? So that's our formula. But we don't have 2, we have 6. So let's factor this, and we know that 6 is equal to 3 times 2, so let's factor off a 3. So it's going to be 3 times the 2 tangent of 3 pi eighths divided by 1 minus tan square of 3 pi eighths. And in this case, x is going to be 3 pi eighths. So we get 3 times the tangent of 2 times 3 pi eighths. Okay? Or that's going to be 3 tangents of 3 pi fourths. All right, since that's going to simplify, we can simplify that out. And then the tangent of 3 pi fourths, well, remember, tangent is y over x. And so if we go to the unit circle, at 3 pi fourths, we get root 2 over 2 divided by negative root 2 over 2. That's going to be root 2 over 2 divided by negative root 2 over 2, or that'll just be negative 1. So this becomes 3 times negative 1, or negative 3. Okay. Of course, we can always try to throw this into our calculator. Okay. It might be difficult for us, though, to get the syntax in our calculator correct with some of this stuff. Right. A couple last examples of using our double angle formula and verifying some identities. So we have this the sine of 2x minus tan x is equal to tan x times cos 2x. Let's operate on this side and just use the formula that we have our 2 sine x cos x minus tan x, okay? And that's just by using our double angle. Let's use the ratio identity on the tangent. So we get 2 sine x cos x minus sine x over cos x. Okay, so remember that's our double angle, that's our ratio identity. Now let's get a common denominator. Okay, and what I'm going to do is I'm going to multiply so that way we can get like one single expression. And so I'm going to multiply this by cos x over cos x. Okay, so that way we get a common denominator. This cos times cos will give us a cos squared. Okay, and so when we try to get a common denominator, this is going to turn into 2 sine x cos square x minus sine x over cos x. Okay, so we just get to our least common denominator. Notice that there's a common sign that we can factor out. Okay, so I'm going to factor a sine of x out of this, and that's going to leave me with 2 cos square of x minus 1. Okay, just by factoring that out. Okay, so that's just greatest common factor. And then at this point, we recognize this right away as the cosine of 2x. This is our double angle formula. Okay, so we can now write this as sine x over cos x times, if I were to just break this off, 2 cos square x minus 1. Okay, so that's just by a little bit of algebra there. Okay, and then we know that sine over cos is tangent of x. Okay, so this is our tangent of x. And then this is going to be our double angle for cosine. Okay, so that's just our ratio identity as well as our double angle identity. Okay, and I think we're done because that's exactly what we needed to show. Tan x cos 2x, tan x cos 2 of x. Okay, so we verified the identity. Even easier is this one, sine square plus cos 2x equals 1 minus sine square. Now, we know that cosine square or cosine of 2x has 3 different formulas. But if we want to make it look like 1 minus sine square, we probably want to use the one that doesn't have any cosines in it. Okay, and you might remember that this is equal to 1 minus 2 sine square of x. And so this expression will become 1 plus, and then the cos of 2, this will become sine squared, excuse me. So I started copying down the formula instead. So we just drop down the sine square, and then our cos of 2x becomes 1 minus 2 sine square of x. Okay, so that's just our double angle again. And then if we combine like terms, okay, that's just going to become 1 minus sine square of x. That's just by adding like terms. And we're done, okay, because that's exactly what we needed to show. Okay, all right, so that concludes everything with the double angles. Now, the next video we're going to start taking a look at is we're going to take a look at our power reducing formulas. Okay, so, and then finally, we're going to finish off by looking at half angle formulas.